Hello guys, welcome back to my channel. Please remember to like and subscribe. For today's topic, we'll be looking at the total surface area of a cube. Now on screen we have a cube and we're going to rotate the cube so you can look at it. If you look at the faces, you will notice that all the faces are made of squares. You can even pause it and count the units from the axes. So if you count on any axis here, and we have three axes, you would notice that you would have gotten 4 units in all direction. If you want to look at the top and the bottom, a similar concept will apply. Right? So we have 4 units in all direction. So you can just look at it go. Right? So all the faces are the same. Now the question is, how many faces do I have? To unveil the amount of faces, we're going to examine the net of the cube. So let us just show you what the net looks like. So if we were to unveil a cube, look at the faces, the net would look like that. Now what I've done again is to put all the faces in different colors so you can easily see them. So we have 1, 2, 3, 4, 5, 6 faces. And all of these faces are squares. Now a square has a single dimension, which is a length, because all sides will actually take on that dimension. So the question is, how do I get the total surface area of a cube? Since all the faces are squares and all the squares have equal dimension, we can all agree that we can find the total surface area by simply finding the area of one square and then multiplying that by 6. So 1, 2, 3, 4, 5, 6. 6 squares, all of equal dimensions. Right? So I only need to find the area of one. And then I multiply that area by 6. And I get the total surface area of the cube. And of course, we know that the area of a square is L squared. So for 6 of them, it would just be 6L squared. And we're going to examine an example after this. So you can just look at the net, and understanding the net conceptually will help you to better understand how to approach a question like this in an exam. Let us put our net back together and see what happens. There we go. And there goes our cube. So for a typical exam scenario, you only need to be given a single dimension. Alright, so we can say that the total surface area would be equal to, we all agree that a cube has 6 faces. And if you look at the diagram on the screen, you could probably pick them up. You have one at the front here, one on the right, one on the left, one at the back, one at the top, and one at the bottom. There's our 6 faces. Each face is a square, and each face has a length of L by L. However, since that all the dimensions are the same, we only need to give it a length of one dimension. And there are 6 of them, so the total surface area would just be 6L squared. And that is a simple formula for a cube. Rather, for the total surface area of a cube, to be specific. So here's our typical question. So we have a cube, and the question says find the total surface area of the cube above. Of course, you do know that in an exam, the cube will not be drawn to scale. Well, mine is not so pretty, but of course. So we start with the formula for the total surface area. We know that the total surface area, TSA as short, is equal to 6L squared, as we have 6 faces and each face has a dimension of L by L. So by putting 6 meters there, we can actually put 6 meters here if we want, and 6 meters on any side. So this is going to become 6 multiplied by 6 squared, which turns out to 216. And never forget a unit, square meters.